Right. Yes. Is that? So to understand that, what is the question? Can you give the question? Please? Okay, the question is the proton and electron simultaneously enter into a region which uniform magnetic field acts normal to the motion of both particles. Frequency of revolution of options. For the proton is greater than that of electron. The electron is greater than that of proton. The proton is equal to that of electron. They are having the same frequency but revolve in opposite directions. Both have the same frequency but revolve in opposite directions. So let us try to understand. Proton and electron simultaneously enter into uniform magnetic field. Let's say this is uniform magnetic field acting into the cross means into the plane. In this region, actually electron enters here normal to the magnetic field and proton also enters. So you know how what happens to this is if it enters it's a velocity. It is mentioned that simultaneously enter into the region with uniform magnetic field within which uniform magnetic field is normal to the motion of both particles. So the entered means you can understand that if they enter it's same velocity, right? What you can understand is if it enters in the magnetic field B, force acts on it. Force is given by force, and the moving charge in the magnetic field is given by F is equal to QVB, QB sin theta, or QB cross B. QB sin theta is the theta is normal. It is actually QB cross B or QVB sin theta cross product. Right? Where sin theta is angle between velocity vector and the magnetic field vector is 90, so sin 90 is 1, so you can write it as F is equal to QVB. In which direction it acts is as the direction of it is given by Q into V cross B. V cross B. Direction is direction of force if the charge is positive charge. The direction of force will be perpendicular to this. I can use the right hand thumb rule to represent that. Whereas if the charge is negative, then the force direction will be opposite to the cross product, opposite to the cross product relation. So you can say V cross B. B is into the plane, so V cross B will upwards. If it is positive charge, force will be upward direction. If it is negative, because it is negative charge, force will be downward, so it will deviate in this direction. If it is an electron, if it is a proton having same charge, so and this because it is a positive charge, same force Q acts on it, but V cross Q into V cross B, but same Q will be force acts because same charge is same, B is same, B is also same force acts but in a upward direction. So as a result, it will deviate and it will move in upward direction. And if you observe, actually, they will undergo motion called circular motion because the force always, if it is velocity, it always perpendicular to the direction of motion. So you can say it will. This is velocity, force will be in a normal direction, so it will undergo circular motion. Here also, it will be always velocity is this, force will be this. So like this, if you observe, it will undergo circular motion. But the question is about the frequency they are asking the question. Now for electron and a proton, as both are undergoing circular motion, let us say this is when they are moving in circular path, the any particle is moving in circular path, the force which is holding them in circular path is centripetal force. So centripetal force m v square by r is providing providing by magnetic force. So QVB provides this centripetal force picture. If you consider electron, mass of electron into velocity is same by radius of electron is equal to charge of electron same as that of proton. Velocity and magnetic field also will be constant. It is equal to this. On simplifying this, you can say radius RE is equal to mv by mass of electron into V by QB. As all are constants, I can say R is directly proportional to mass. Yes. From this, so from this, what you can say is R is proportional to m. R is proportional to m. So radius of electron by radius of proton is equal to mass of electron by mass of proton. As mass of proton is greater, obviously from this itself we can say that Radius of mass of electron is lesser than mass of proton. Means the radius of proton will be greater than radius of electron. One thing you can understand. That is one part. Second part. That is one part. Second part is actual part, main part of the question is what is the ratio of the frequency? How the frequencies of this will varies. Frequency is nothing but reciprocal of time period. So it can be expressed as time period is nothing but circumference, that is distance by velocity, that is nothing but circumference 2 pi r by v, that v goes here, right? You substitute any of this, say for example r here, from this r, r is mv by qb, so it is, you can express it as v by 2 pi r is mv by qb, so qb goes here, so v cancel, is equal to qb by 2 pi m. Q of both the charge of both electron and proton is same, magnetic field is fixed, 2 pi is fixed, so you can say frequency is inversely proportional to mass, right? And so with that you can say frequency of so if you see the options, frequency of revolution of proton is greater than of electron, no. Electron is greater than that of proton, yes. Proton is equal to that of electron, no. Both having same frequency but revolve in opposite directions. Actually frequency of electron is greater, but the thing is they will revolve in opposite directions. That is the thing, but they are not having same frequency. So okay. We have to check about radius. Then by making use of the actually directly also you can take it because the radius is anyway is not there. So that you actually just you don't need to even do this one, the first part. Directly you can say as frequency is equal to reciprocal of time period is nothing but 2 pi r by v goes here, and by taking the you have to take the expression for r. This is what you can have to first do. So no need to here compare the radii. You can first try to get the radii, and r after substituting this you can say as v by is 2 pi, r is nothing but q v q q radius is mv by qb, mv by qb. So qb here. So whereas the rest cancels, so it becomes qb by 2 pi m. 2 pi m. So directly you can say f is proportional to 1 by mass. Only we have to just derive an expression for what you call radius. And you can add such to it. So this. Okay. This actually I have discussed it. This I discussed. This one. So we can just see the question was. The question is the work function of a metal is 2.5 electron volt. Work function of a metal is 2.5 electron volt. The maximum kinetic energy of photoelectrons. The maximum kinetic energy of photoelectrons emitted if radiation of wavelength, if radiation of wavelength 3000 angstrom unit falls on it. What is the maximum kinetic energy Ke max of photoelectrons emitted if radiation of wavelength 3000 angstrom unit falls on it is provided the value of constant H is given as 6.63 into 10 to the power minus 34 joule second, and the speed of light in free space is given as 3 into 10 to the power 8 meters per second. So how to get this? By using Einstein's photoelectric equation, we know that energy of incident photon h nu is equal to work function W plus kinetic energy. So a part of this incident energy will use it to overcome the work function. The remaining is imparted as kinetic energy to the ejected photoelectrons. Right? So here we are asked to find what is Ke max. So let us take this Ke max. Ke max is equal to h nu minus W. Here W work function is given in terms of electron volts. So you don't need to worry about this. It is directly given. What is h nu? Wavelength is given. If a light of wavelength this much is incident, then what is kinetic energy of maximum kinetic energy of ejected photoelectrons? We are asked to find. So we have to express this in terms of wavelength. So hc by lambda minus W. Let's see by lambda minus W. But here W, that is work function, is given in electron volts. So if we can take this also in electron volts, then it is easy to take the result of this. Then depending on the options, if the final option is in electron volt, you can keep it as it is. Otherwise, you can convert it. The options are given in joules. So here, as because here if you take the wavelength lambda, the given value h and c values in SI units, you get this part of energy in joule, but this is given in electron volts. But both you should have to have both of these in the same units. You have to remember here one shortcut that hc by lambda hc by lambda can be taken as is nothing but energy. This energy can be taken as 12,400 if the wavelength is taken in angstrom units. This can be equated to 12,400 by the wavelength in angstrom units, electron volt. This is energy. Energy. This part can be expressed as 12,400 by wavelength in angstrom units in electron volts. This entire energy will be in electron volts. So if you bring this over here, you can write it as 12,400 divided by lambda in angstrom units is given as 3,000 8. So you can by substituting this 3,000 angstrom units, whereas W is 2.5 electron volts only. Both are given electron volts. And simplifying here, say two zeros gets cancelled. So it's 124 by 30. You can write it as 124 by 30. 120 by 30 means 30 force. 30 force is 120, but it is more than 4. That means approximately you can say, or you can say if it is 30, if you send this 0 here, becomes 12.4 by 3. And simplifying this, you can say 3 force 12.13 will get approximately. Minus 2.5. This will be an electron volt. This also will be an electron volt. So the difference between these values will give you approximately 1.6 electron volt. 1.6 only, that is Ke max. But if you see, the options they have given in terms of joule. So to convert this into joule, this is the kinetic energy of ejected maximum kinetic energy of ejected photoelectrons in electron volts. To convert this into joules, we have to what? Because we have to say because 1 electron volt is equal to 1.6 into 10 to the power minus 19 joule. You can say Ke max is equal to 1.6 into 1 electron volt is 1.6 into 10 to the power minus 19 joule. So on simplifying this, you will get a 2.56 into 10 power minus 19 joule. That is the Ke max. Right? So it is given as two photons of energies and twice work function of metal per instant on the metal surface. The ratio of maximum velocities of photons emitted in the two cases respectively. The two cases respectively. Right. Really? We'll see. We'll check. So, is this question number two? Is there not? Two photons of energies of twice and thrice. Photons of energies twice and thrice the work function. So, energy of the first photon, that is instant energy of energy means instant energy of first photon is twice the work function. And instant energy of second photon is thrice the work function. Two photons of energy twice and thrice the work function of a metal arrangement on a metal surface. Arrangement on a metal surface. And ratio of maximum velocities of photoelectrons with even this photon incident, then what will be the maximum velocity of the emitted electron, photoelectron, and this incident, what will be the maximum velocity of the emitted electron, ratio of those maximum velocities. That means, then what is the ratio of V1 by V2, maximum velocities, is equal to what we are asking. We know from Einstein's quadratic equation, kinetic energy is equal to instant energy, which that is actually you can take it as this is h nu one. This in u1 I have taken h nu two I have taken as u2. It is equal to h nu of the first one plus work function. Work function on same metal, so work function is constant. So from this we can take a no. This is sorry. Yes. Actually, h nu one is equal to work function plus ke1. Ke1. Yes. So from this, if you can write ke1, kinetic energy of the first photon electron emitted due to the first photon is h nu one minus w. Minus w. Right? So this K1 is nothing but half M V1 square. It is equal to h mu 1 minus W. So yes. So this is 2W. For the first one is 2W. So you can write it as 2W minus W is W plus W. So half M V1 square is W. So we can write we are asked to find in general if you consider that is here we come across this, but in particular in this case I can say half m v1 square is w. Let's take this as equation 1. Whereas in second particle case, kinetic energy of second particle is h mu 2 minus w. It is 3w minus w. It is 2w. So it is half m v2 square. V2 square. Let us say take this as equation 2. So by taking the ratio of 1 and 2, we get half m v1 square by half m v2 square is equal to w by 2w. Will gets cancelled, half m also gets cancelled. So v1 by v2 whole square is equal to 1 by 2. v1 by v2 is equal to 1 by root 2. They're asking to find the ratio of first to second or second to first. That is not important. Ratio of maximum velocities of the photons emitted in the two cases. First and second, twice and third. Okay, it will be 1 by root 2. Yes, 1 is to root 2. Yeah?
W में 0.9 minus 2 by
What is given here is what the question is the energy of emitted photoelectrons from the metal is 0.9 electron volts. Let's see the next one. Question number 4. The question is the energy of emitted photoelectrons from a metal is 0.9 electron volt. Energy of emitted photoelectrons means kinetic energy.
I know
Kinetic energy.
no
Energy of emitted photoelectrons. Then work function of the metal is 2.2 electron volts. Then energy of incident photons is yes. So actually, if you say if there is a metal surface, if a photon of energy h nu incident here on this, it will be having some work function W. A part of this will be h nu is equal to work function. A part will be spent for work function. Remaining is given as kinetic energy. So electrons will come out. Photons incident, electrons will come out with what energy? Kinetic energy. So electrons and also called as photoelectrons will move with kinetic energy. So here it is mentioned that energy of emitted photoelectrons means kinetic energy of emitted photoelectrons. So kinetic energy is equal to 0.9 electron volt and work function of the metal W is equal to 2.5 electron volt by 2.2 electron volt. Then what is the energy of incident photons is equal to what? Directly you can say h nu is equal to W plus K. So 3.1. So it is 2.2 plus 0.9 is equal to 3.1. 3.1 electron volts. That's it. Right? That's it. Yes. Station building further station building for photo replication photographs. Further effects are included in this common variables we discuss now. Power have been discussed. So power intensity, these relations. General relation between current and intensity in this calculations are discussed. So the question is, so what is given here? For the third question, the work function of a metal is 2.5 electron volt. Work function of a metal W. W is 2.5 electron volt. The maximum kinetic energy. So the maximum kinetic energy of the photoelectrons emitted if radiation of wavelength 3000 angstrom units falls on it. If radiation of wavelength this falls on it, what will be the maximum kinetic energy? Is it right? So you can say we can by using photoelectric equation, Einstein's photoelectric equation. We can say from from Einstein's Einstein's photoelectric equation. Photoelectric equation. You know, the energy of incident photon should be equal to sum of work function plus kinetic energy. Means on a metal surface, if a photon of energy h nu incident, it is spent in two parts. A part will be spent to overcome the work function of the metal surface, and the remaining energy will be given to the given as kinetic energy for the ejected electrons. These are photon. When a photon of energy actually instant is sent in this. No. It is not so. Photoelectric emission. Photon is giving electron, not fast moving electron is giving another electron. If it highly energetic electron forms and if it gives the another electron, that is secondary emission. This is photoelectric emission. Photon is giving electron. Okay, this process h nu is equal to sum of these two, that is work function plus kinetic energy. Work function plus kinetic energy. So h nu is equal to work function plus kinetic energy. Here, when a metal surface is having this work function and when a radiation of wavelength this much incident on it, what should be the kinetic energy, maximum kinetic energy of the ejected photoelectron? So K max is equal to h nu minus W. H nu minus W. So that W is given as 2.5 electron volts. Already it is given. And here mu is not given, lambda is given. So let us write it as Hc by lambda. Hc by lambda. Hc by lambda minus W. It is given in electron volts. This also we have to take in electron volts. But if you substitute these values in normal actual values, we get joules. So to avoid that, we have to remember this expression. Here, to get this, we have to get it from here. Hc by lambda can be in electron volts form can be expressed as 12,400 by lambda in angstrom volts. If we take, then we will get this entire value in electron volts. This if you substitute here and substitute the value of lambda in angstrom volts, then you will get 12,400. This is 12,400. You take this as 12,400 by lambda and angstrom units in electron volts. Entire value will get in electron volts. So 12,400 by 3,000. This is in angstrom units minus 2.5 electron volts. Now this is in electron volts. This is also in electron volts. Now on simplifying this further, two zeros cancel. This zero if you set here becomes 12.4 by 3, and if you cancel further, you get 3 4 12.13. 4.113 electron volt minus 2.5 electron volt. Difference will be 1.6 electron volts. So that the options are given in joules. So we have to convert this electron volt into joules. 1 electron volt is equal to 1.6 10 power minus 19 joule. So by multiplying this, we get 1.6 and 1.56 is 2.56 10 power minus 19 joule. Okay. Nothing else?